Good afternoon, everyone. Welcome to the second EU Space Surveillance and Tracking webinar. My name is Oliver Rajan. I'm the Communications Manager of the EU Satellite Center, and I'm very honored to be the moderator of this event today. The objective of this webinar is to present the EU Space Surveillance and Tracking latest developments and how the different operation centers and SST Front Desks are currently working for providing the SST services. The three services: collision avoidance, re-entry analysis, and fragmentation analysis. We will also present real cases of potential collisions in space, object breakups, and re-entries with our panel of SST experts and users. Let me now introduce the distinguished panelists, which we have the honor to be participating today. We have Pascal Fauché from CNES, Maria Antonia Ramos from CDTI, Cristina Perez from CDTI, Florian Delmas from CNES, João Alves, my colleague from SATCEN, Pierluigi Righetti from EUMETSAT, Lieutenant Moreno Perroni from the Italian MOD, Juan Escalante from the European Commission, Christophe Morand from the European External Action Service, and Rodolfo Munoz from the European Commission. Let's take a quick look at the agenda. I'm sure you're all aware, but just to understand the basic structure. The whole webinar is divided into two blocks of 1.5 hours each, 90 minutes, divided by a 10-minute break in the middle. We will start with the SST support framework presented by Dr. Pascal Fauché. We will then have the EU SST architecture and service provision model by Maria Antonia Ramos Prada, followed by the EU SST operational collision avoidance service presented by Cristina Perez, Florian Delmas, and João Alves, followed by Pierluigi Righetti, who will present the user perspective from EUMETSAT. We will then have the 10-minute break and continue in the second block with the EU SST operational fragmentation and re-entry analysis services presented by Lieutenant Moreno Perroni and João Alves, and then also commented by Mr. Juan Escalante from DG ECHO. The next slot is then the safety, security, and sustainability of outer space, the 3SOS initiative, presented by the EAS Space Task Force, Mr. Christophe Morand. And we will finally conclude with the European Commission with Rodolfo Munoz. To have a bit of an interaction, in which we highly encourage to all participants, we will, after every slot, after every thematic slot, not after every single briefing, but after every slot, is 5 minutes, approximately 5-minute time for questions and answers. Please feel free to all participants to already submit your questions in the Q&A section to the panelists. This way, we can already take note of the questions and then address them directly to the respective panelists afterwards. As you know, in these special circumstances, the whole event has to be online in a virtual environment, and we chose the Webex software for this, both for the broadcasting, but also for the interaction with an audience. In case you know of anyone who did not manage to register and sign up for this event directly, please let them know that this event is also being streamed on the EU SST Twitter channel, and they can also interact via the hashtag EU SST and EU SST webinar. The event is also broadcasted on our web page, EUSST.eu. And if there's any other comments, any issues you have, or comments you would like to send to our SST team, please use the email sst.info@satcen.europa.eu. Before we start with our first briefing, let me just explain to you 2 or 3 issues, how to best use the Webex platform. Because as I mentioned, we would like to also interact with you, and we would like to have your feedback. For those of you connecting from a laptop, your current screen will probably look about like this one. On the top right corner of the main screen, you'll find a button where you can choose the main appearance of a dashboard by selecting video strip view, side-by-side view, or float to panel view. On the left central part of the slide, you'll find a couple of buttons to zoom in and zoom out on the presentation in case you need to magnify anything or take a closer look at one of the slides. Now let's quickly go over the panels. The place reserved is on the right-hand side of the screen. You can activate 4 panels. For participants, Q&A, chat, which only will be used by the host to send something of general information, and the polling. To open on any of the panels, click on the small arrow on the right side and collapse it again like that too. If you want to completely hide any of the panels, click on the cross like you normally do with Windows anyway. If you want to show it back, click on the button at the bottom of the panel pane. For submitting your questions during each slot, you should type them on the Q&A panel. Make sure to choose all panelists as recipients so the questions can be read by us and then given to the panelists after the Q&A session of each slot. And finally, and also quite important, some polls will appear during the webinar to get our best understanding of our audience. So we'll ask you some questions and we'll be highly encouraging you to respond to them. Polls will appear automatically on the right side. You'll have 30 seconds to provide your inputs, and to conclude, important to also press the submit button. Don't just click on the answer, but actually submit it, because you can change the answer until you actually press submit. And for this, we would like to do a quick warm-up exercise with you. First question, how familiar are you with the space surveillance and tracking? And you can choose 4 options, as you see on the right-hand side, from not familiar to extremely familiar. But now is the time. Please choose one of the 4 options and don't forget to press the submit button at the bottom. Okay, time is up. Let's have a quick look at the results. Here we go. So most people actually chose somewhat familiar, which is understandable. So it's quite a high level of expertise in our wide audience. You saw that more than 100 people chose that one, and some actually chose extremely familiar. So we have some real experts. That's very good. Let's see if we find the right appropriate level of questions then from these special experts. Okay, I think we're all set now. So we're ready to go for the first briefing. The first session of the webinar is called SST Support Framework, Safeguarding European Space Infrastructure. Dr. Pascal Fauché will present us this briefing, and I'm very happy to introduce our first speaker today. Pascal Fauché is the chairman of the SST Consortium. Almost 20 years, he held various positions at the CNES headquarters as International Relations Advisor and Program Manager. For the last 10 years in the Defense and Security Office, he's been responsible for space security, SSA, SST. Also as a French delegate at different international programs or initiatives like ESA, UN COPIUS, etc. Pascal, the floor is yours. Just to activate the microphone.
Oh, I'm sorry. Thank you, Oliver. Thank you for the nice introduction. Good morning, good afternoon, good evening, everyone. I'm very happy to attend this webinar in the current circumstances, and to all the attendees from Europe and around the world. I do hope that you are well and healthy in your country. So I would like first to thank Joao and its great team from the European Union Satellite Center for organizing this second webinar dedicated to operations in European space surveillance and tracking. I wish this webinar will provide a good deep dive into our sensors operations, database, service provision, and on my side, I'm going to provide you with an overview. So, yeah, and a refresher on EU SST. So, what is the EU SST? It's a European framework and soon a program for multilateral capability in space situational awareness set up by the European Union. and it's been implemented through a consortium of member states since 2015. Our goal is to ensure the protection and resilience of space infrastructures, including our flagships program, Galileo and Copernicus in Europe. We also aim to develop our SSA capability and to achieve a higher level of strategic autonomy in Europe, and thus in turn to contribute to a global burden sharing and act as a reliable and capable partner. We are fully operational in this initiative. We cover all the spectrum of space situational awareness operations, including sensor, data processing, and service function. We pull together our existing surveillance and tracking sensors. We share thousands of measurements every day or upon request through our European database. We provide advanced operational services, including collision avoidance, in order to ensure safe and sustainable space operations. And today we are very proud to have a growing user community, and some of them are participants in this webinar. We protect from risk of collision. You will see that later in the presentation by Marianne. We protect totally 147 spacecraft of the European Union and its member states, civil, military, and commercial in all of these regimes. We have a 40 years legacy in satellite operations, a huge flight dynamic expertise, which brings trust for our European operators, and those spacecraft operators agree to share their ephemeris and monitor plan with us. So we can also activate our network of sensors to track and refine the orbit of the secondary object in case of a risky conjunction, for instance. So yes, we are fully operational, and this will be the subject of this webinar. In parallel of our operations, we also have an important research and innovation program to improve our level of performance and strategic autonomy at European level. More than 60% of our budgetary effort is dedicated to this objective, and we mainly rely on our European industry, of course. Our priority is to upgrade and develop our sensor network, our database, and our portfolio of services. And we also have an important program of research and technology studies and simulation to pave the way for the evolution of our European capabilities to respond to new challenges in space. We are also security relevant. We mature and expand into the upcoming EU space program. I will come back on these two topics later in my presentation. So, governance. We operate a unique governance model in this European space cooperation that is different from our other approaches used so far. Our governance allows participation of member states that wish to contribute with their SSA capability without building control of their assets. This group is currently composed of 7 member states: France, Germany, Italy, Spain, Poland, Portugal, and Romania. We have a particular setup where we rely on a mix of civil, military, scientific, and commercial sensors. We are subcontracting a lot to our European industry. It corresponds to more than 80% of our budget. More and more commercial actors are involved in our model, and this effort should be continuing in the future. We have also established a very good cooperation with the European Union's Satellite Center, which is responsible for the service provision portal available 24/7 for European users. And of course, all this program is overseen by European Commission. And we have very close relations with our Commission, of course. Maybe I would like here to inform you that our British co-founded partners just left the SST Consortium. That's the reason why they do not appear anymore in this presentation. It happens just a few weeks ago in the context of Brexit. On the 2nd of October, the European Commission took the decision to exclude UK-based legal persons and undertakings from participating in programs granting access to security-related sensitive information, and EU SST has been considered as one of them. On this slide, you can see the various levels of governance, from working level and management level to the decision-making level. So the working level corresponds to all our operational activities as well as research and technological activities. The management layer coordinates the execution of those activities, and I would like here to mention that we have a brilliant project coordination team led by José María Hermoso from Spain. They're really doing a tremendous job on these aspects. At decision-making level, you see that we have 3 committees. We have a security committee chaired by Mark Becker from Germany, and a technical committee chaired by Marian Ramos from Spain. They both report to the steering committee, which is the highest decision-making body of the consortium, responsible for policy and strategic objectives, decisions on financial matters, and engagement with the European Union, external stakeholders, and international interlocutors. We also have a coordination committee in our governance between member states and the European Union Satellite Center. And as a good practice of transparency and confidence building, European Commission has been invited to participate to all our committee meetings as a permanent observer. So this is very positive. Security. We are security relevant. EU SST is a civilian network. It must be able to function effectively, taking into account the duality of the SST domain and the important security dimension. And for this purpose, we specifically include military and security stakeholders across our formal internal governance. And in our setup, we have the privilege to work on a daily basis with our MOD and SA colleagues. And we are very content to have them on board, to have this diversity of cultures inside the consortium. And this is something definitely that we should keep in the future. So we share, as I said before, data from different sources, civil, military, scientific, and commercial. Some precise information on the nature, specifications, and location of certain objects may affect the security of the European Union, its member states, or our allied partners, or relate to performance and control of sensors. So to this end, our dedicated internal security body oversees all matters relating to data security and operational risk. So for the moment, you see on this picture here that we do not have a comprehensive architecture of data sharing agreements in Europe. All 7 member states of the consortium have that SST data sharing agreements at unclassified level with the US. Some members have agreements at class level. Others are working on the MOD, DOD channel to update the current SST their SST data sharing agreements at class level. And in Europe, only France and Germany have established an SST data sharing agreement with each other at class and class level. So you see that in the absence of a comprehensive set of data sharing agreements in Europe, we deal with the security interest of the respective partners and their allies through an internal data policy, which is very important. The EU SST Security Committee provides classification guidance and develops security requirements that cover, for instance, how the EU SST protects sensitive information such as data on allied space objects. And this will be my last slide. As I said in my introduction, we mature and expand. And looking at the future in the upcoming financial framework of 7 years in 21, next year, SST is going to mature into a fully fledged security component program. It will become a third flagship European Union space program after Galileo and Copernicus. So this is very positive. The governance model with control over national sensors will remain in place. We have already started the process to build gradually the future SST partnership involving today 16 member states of the European Union. And so it means that 9 additionally European Union member states have indeed expressed their interest to join us to contribute to European SST capability. It shows that right now in Europe, there's a political awareness on the importance of space situational awareness, and that this topic will continue to grow in Europe's agenda. EU SST, the last bullet point, is even regarded by European Commission as a fundamental operational capability in Europe, precursor of a European space traffic management system, according to our Commissioner Thierry Breton. It is still a topic to be discussed at political in Europe, but in the meantime, I would like to say that EU SST has demonstrated with its achievements and its challenges to be a successful multilateral cooperation at the intersection between space safety and space security, addressing the important duality dimension of the SSA domain. Maybe one of our key success factors is that we have always adopted an incremental, bottom-up, and pragmatic capability approach that looks for operational solutions to practical problems. And I would like to conclude my remarks here by saying that over the years, we have grown as a group of member states, building and deepening trust together, moving into the right direction. And I'm very much impressed. It's really a pleasure to work with so many talented people and experts in Europe in the SSA domain. And I'm very much looking forward to the next technical presentation. Thank you.
Thank you, Pascal. Really excellent. I think that's a perfect kickoff. If you touched on governance, the security aspect, the future perspective. For me, most importantly, really is that there is a big effort of various EU countries to really connect well and together create added value. And I think that was a very nice presentation to show what is possible with quite some ambitious outlook, as you said in the last lines, to be discussed. We'll see what member states propose in the future. Thanks a lot. Next session is on EU SST architecture and the service provision model. I'm very happy to introduce Maria Antonia Ramos Prada. She is the chair of the SST Technical Committee with the structure we've just seen by the last briefing. And she joined the EU SST project in 2016 after 11 years working at the European Space Agency, and in total has more than 20 years of experience in the space domain. Marianne, floor is yours. Just remember to put on your speakers. We hear you so much better. Thanks a lot.
Thank you, Oliver. Thank you for your introduction and good afternoon to everybody. As Oliver has just said, I'm going to introduce you to the architecture and service provision model. But it will just be an appetizer so that you want to know more. The main attraction will come later with real-life examples that my colleagues will explain you. In the next minutes, I'm going to explain you the functional architecture of the EUSST system and the data flow. We can call it the behind the curtains work. From that starting point, we will go into the sensor network, the EUSST database and feature catalog, which are the backbone of the system, the service provision from the generation of products at the operational centers to the front desk and to the user, and we'll eventually show you how we control and how we measure what we are doing and what we are achieving up to now. Here in this slide, I will explain the data flow, starting from the generation of the measurements, although we could have started at any point because you will see there is a circular process from which the service generation feeds back into the sensor network. As explained before by Pascal, these national sensors are under the control of the member states and produce observation and measurements of the objects orbiting around the Earth. This network of sensors produces every day hundreds of thousands of measurements. Then these measurements, after a preliminary process of formatting and correlation, go into the national databases and the national catalogs, where we keep objects in LEO, MEO, and GEO objects. From the national databases, tracks are transferred following the data policy rules to a centralized EU SST database. All national centers have access to these tracks stored in the EU SST database, which makes possible an efficient data sharing within the consortium. In this way, the operation centers that are providing the services, collision avoidance, re-entry, and fragmentation, have access not only to the measurements produced by sensors under their control, but to the measurements produced by the whole sensors that contribute into the network. Then, once the products are generated at the OCs, they are transferred to the users through the front desk. And in the case of the CA, there is also a direct interaction between the OC providing the services and the users for high interest events. High interest events are tailored by the users depending on the risk of the event. And in this case, there is a direct interaction in which additional information can be requested and also support to maneuver is offered. The feedback that I was mentioning before is related to this arrow here. If during the processing of the data it is observed that additional information is needed, for example, for these high interest events I was just mentioning, a very risky re-entry that can go over the European territory, an object that needs to be refined because its orbit is increasing the covariance, then a tasking request is issued, and the sensor network, on top of their business as usual, will pay special attention to those objects and provide additional measurements. And now that we know already the data flow from the observations to the generation of products and the delivery to the users, we will go a step deeper into each of the different parts of this diagram. So here in this world map, you can see the sensor network that we have distributed around the globe. We have 4 lasers located in Spain, Italy, Austria, and Poland that are providing high accuracy measurements of LEO objects. Then we have 10 radars, 3 surveillance, 1 monostatic one working in VHF, located in France, and with a bistatic configuration. 1 monostatic radar working in L-band in Spain, the S3PSR, and another monostatic radar working in L-band also located in Germany, that is the Gesta. And then we are complementing this network of radar with 7 surveillance radars, the Tyra, that is an imaging radar, the 3 SATANs, the MFDR, the Viralet, and the Virales. And then we have the network of telescopes composed of 32 telescopes, 17 surveillance, and 15 tracking. Here it is very important to highlight that we have surveillance capability in all the main areas in the world. We have DBEATA providing surveillance capability in North America, Tarot and Polonia, Tarot Chile and Polonia, providing surveillance capability in the area of South America, the Moon Base and the Tarot Reunion providing surveillance in South Africa, Solaris 3AB in the Oceania area, and Anjin-San in Asia. And then also the European area is well covered. And then all the tracking radars giving support to this surveillance. The next step in the data flow is the database and the catalog, the EUSST database and catalog that are allowing the collaboration and the data sharing among the member states. Tracks are stored in the joint platform that started operations last year in April. Measurements can be accessed by all EUSST consortium members, and also the tasking request and the reply to this tasking request is stored in the EUSST database in form of measurements. Nowadays, the consortium is evolving to a catalog precursor using as a starting point this EUSST database. Measurements coming from the database will be pre-processed, analyzed, and correlated, and the correlated measurements will be used to determine and refine the orbit of the object. The development is ongoing right now, and it is expected that it will enter into operations during next year. It will be fully ready in December 2021, and all the member states will have access to this catalog of orbits, this centralized catalog. And now we come to the service provision. Already mentioned, there are 3 services that are offered by the consortium: the collision avoidance service, the fragmentation analysis, and the reentry analysis. The collision avoidance is a user-tailored service. When a user registers for CA, it is allocated to one of the 2 OCs providing the services, either the French or the Spanish one, and a dialogue is started to agree on the defined service configuration document, in which the user can decide the criticality of the products that will be received, the thresholds at which a direct communication shall be used, the point of contact for each of these cases, and so on. The Spanish and the French OC are working in hot redundancy. What does it mean? This means that if the OC allocated as primary interface fails, the other one will take over immediately and as seamless as possible. For that, the service provided by the 2 OCs has been harmonized to make sure that an enhanced analysis and risk mitigation support is provided by both of them, with covariance estimation, hard body radius estimations, probability of collision sensitivity analysis, collision avoidance maneuver support, and so on. In case of a high interest event, as already mentioned, a direct dialogue to the user is established and additional tracking of the involved objects by the sensor network is asked. The products offered are autonomous and enhanced CDMs. Autonomous means that the product, the CDM, the conjunction data message, is generated using exclusively data coming from our sensor network. There are also CA reports and monthly reports. All this information can be accessed through the SST portal, where the user can download through the API and the web interface all these kind of products, and also upload information in the form of ephemeris and maneuvers to complement the analysis that is provided by the OC. Also, all the documentation is available, and the notification alerts can be configured, as well as checking the evolution of some of the main parameters, like the probability of collision, can be done through the SST portal. Now we go to the next service, that is the Fragmentation Analysis service, offered by the Italian OC, that deals with the detection and characterization of in-orbit fragments. It offers 3 main features. Sorry, I've done a spoiler. Here, so back here in the services. It offers 3 main features that have associated 3 kinds of products of reports. The first one is the short-term notification, that is an email that is sent to the user as soon as a fragmentation event is detected. So it's a quick reaction of the service, and it informs that the event has happened, and additional information available, like the number of fragments that are known up to that moment. Then when this happens, the sensor network is activated to try to track as many objects as possible, to gather as much information as possible from the event. And the medium-term report is produced based on the orbital parameters of the catalog fragments and offering, for example, Gabbard diagrams. Then a long-term report is produced not later than 3 months after the event, in which additional information is provided, like simulations with breakup models. In case of events that are with social impact, then technical notes are also produced on top of these 3 kinds of reports. All this information, as in the case of the collision avoidance, can be accessed through the SST portal, through the API and the web interface. And then the last service is the reentry service, also offered by the Italian OC, that assesses the risk posed by the uncontrolled reentry of objects in the Earth's atmosphere. Objects that are followed are rocket bodies and any uncontrolled objects greater than 2,000 kilograms or radar cross-section larger than 1 square kilometer. There are 2 main features with 2 kinds of products associated. First one is the list of long-term reentry predictions. showing the objects expected to re-enter in the following 30 days. The second type is a close follow-up of the objects during the few days prior to the expected re-entry date. It shows overflight predictions with ground tracks customizable over the areas of interest. As in the case of the fragmentation, when a re-entry is being followed, the sensor network is tasked to provide as much information as possible of the object of interest, and in special cases, also technical notes are produced. All this can be accessed through the SST portal using the API and the web interface, which includes also the possibility of viewing the evolution of the re-entry window. Now the next step is the front desk. The front desk is the interface with the user, delivering the products generated by the OCs in accordance to the data and the information policy. On top of the SST portal through which the services are accessed, as just explained in the previous slide, it includes also a help desk to give support to the users, and additionally, the user interaction is centralized here, gathering the user needs by a specific feedback campaign, as well as user uptake actions like this one. There are several types of users receiving the services: all European member states, the Council, the Commission, the European External Action Services, European public and private spacecraft owners and operators, and European public authorities concerned with civil protection. As you see now, it's only European users, but in the draft Future Space Regulation, it is proposed that services could be open also to non-European users. In the next two slides, you can see the number of organizations that are registered and receiving the service. Is in total more than 90 organizations, 25 organizations, more than that for collision avoidance, more than 65 for fragmentation analysis, and more than 70 for re-entry analysis. The 25 organizations receiving collision avoidance means 147 satellites that are receiving the collision avoidance service through the two operational OCs that are offering the service in hot redundancy, so half of the satellites in each of them, keeping always the satellites of the same fleet with one single interface. And now, to finalize my presentation, I would like to show you how we monitor the evolution of the EUSST system and the provided services to ensure that we are continuously evolving to meet the needs of our users. We have defined a set of metrics and key performance indicators for each of the functional elements that were shown in my first slide. If you still have it in mind, from the left to the right, we are monitoring the sensors that are contributing to the ESST, including also a specific calibration campaigns that are run every 4 months to check the quality of the measurement. We check the dedication of the sensors. We check the robustness of each sensor to operate. That is, how many times it's in maintenance, how many times it's actually operating. And in the calibration campaign, we measure the noise and the time bias and time bias drift of the measurements that are provided. Make sure that what we are receiving are good quality measurements. We are also checking the database, its availability, and the objects that are stored in it, objects and orbits. We are also keeping an eye on the data sharing. We check the number of measurements that are shared, the number of tracks, the mean duration of those tracks, because if the tracks are too short, then they are not useful for the orbit determination. We check the timeliness to make sure that these measurements are arriving on time, and we check also number of objects and the revisiting time of these objects, so how often we are seeing these objects. We don't need only to share, but to share in a way that can be used for the services and for the orbit determination. We also keep an eye on the tracking requests, how many tracking requests or tasking requests we issue with respect to the events that we are monitoring, and how many of them are we able to resolve properly. So for how many of them we are providing measurements of the requested object, and also in how much time we resolve these tasking requests. In the service provision, we are keeping track of the events that we are reporting, the number of products that we are reporting for each event, and also how many of them are autonomous, as well as the availability of the service and how we reply to a specific request from the users. And then eventually for the front desk and the users, we are checking if the front desk is available. We are checking if the users are actually, the registered users are actually using the service, and new users that are engaged, are being engaged. So we keep track of all the full chain that was shown in my first slide. And now, just before finishing, I would like to show you some big numbers of what we have done during last year of operation. We do a yearly review, and the last one was done just before summer. And here you can see what we did between April 2019 and March 2020. We shared more than 7.7 measurements, more than 400,000 tracks, more than 1.1 million orbits in formats of TLEs. There were more than 14,000 events reported, and there were more than 16 autonomous products delivered. And this was my last slide.
Thank you, Marianne. Really excellent. Sorry.
No, it was just nothing.
Very good. Perfect. I think that really builds well on what Pascal initially explained with the framework. Now you explained very nicely the amazing technological base the whole project is footed on, the sensor network. It's always impressive what is available out there on a global scale and how we can actually use all that data for these services. You explained the database and the precursor catalog, and also the three services, which we will go into detail in the following briefings. So thanks a lot. I think that was a very sound technological foundation, so to say, for what is to come up next. Now, all the participants have been active, and we received several questions. We will focus on just a few of them, given the time. We have a slot of about 5 minutes for this. So I will read the questions which we will discuss in the next minute, and then maybe I'll group them. I'll first present the questions to Pascal and then to Maria, and then I'll give you the word one after the other, I suppose. So first for Pascal, what is the level of autonomy that EU SST pursues? And another question, how are the activities influenced by COVID? What new countries are expected to join? There's the question also to Maria. What will be the impact of new space on EU SST, for instance, with the so-called mega constellations? And again, to everyone, feel free to always send your questions during the briefing so we can prepare them and then ask them to the panelists like we do right now. Pascal, the floor is yours. I think you go ahead, and then when you're done, I think Maria can just continue straight away.
Thank you, Oliver. First, I would like to say that a higher level of strategic autonomy in the SSA domain in Europe should be understood in a logic of partnership and cooperation between like-minded nations, and in particular with our partner, the United States, who remain the world's largest provider of SSA information. That's the reality. So it's very important to share the responsibility of global space situational awareness, to promote international cooperation, to promote better communication and coordination among actors, among operators. And so it means in Europe, our objective is really to develop our capabilities to reach a higher level of strategic autonomy, always in partnership, in collaboration with our US partners. It's really about contributing to the global burden sharing in the SSA domain. This strategy has not changed. So now, in terms of numbers, we have a very important work where we evaluate the different architecture of sensors offering the best performance and the best value for money in Europe. So we have this ongoing work to evaluate our sensor coverage, our cataloging performance, and also according to different budgetary scenarios, As I said before, we use a bottom-up approach. And what I can say is that in lower orbit, using different surveillance radars related with different levels of performance, as a result, I would say that up to 60–70% of objects larger than 10 centimeters would be catalogued in 2028 in one financial framework from now. So it would mean that we will be capacity in Europe to track and survey most active maneuvering spacecraft or maneuvering objects in all orbit regimes. In GEO, our simulation shows that in a few years we will reach quite quickly a full European autonomy on the GOR down to 35 centimeters, both in MEO and in GEO. So yes, we are going into the right direction. We need to have a good coordinated effort in Europe. But again, we shall also remain very humble. Our United States partners are today sharing all the SSA information towards all spacecraft operators in the world. And we use that information. We complement those information coming from the 18th Space Squadron with our European measurements. And we should continue to work in collaboration with them.
I think, Marion, you can go straight ahead to just switch on to, yeah, perfect.
Okay, thank you. So the question was about the new space on EUSST and how will impact our system, the so-called, for example, mega constellations. So as we all know, in the next years, many more objects are expected to be orbiting around the Earth, and this means that the likelihood of collision would be higher, and we are preparing for that. As Pascal mentioned in his presentation, there is also a research and development project line. In this project line, we are working in more efficient algorithms and methods for data processing, for example, using artificial intelligence. This will allow for a better screening of the potential events. And we are also working, as Pascal has just explained, in increasing our sensor network, not only in the number of sensors and the number of objects that we can track and we can detect, but also on the accuracy that we can gather to have an orbit determination as better as possible, so that we are more efficient in the reporting of events and in the tracking of events that are happening to decrease the probability of false alarm events.
Perfect. Okay, thank you both. I think it was a very important groundwork which you two have done, explaining the context, the framework, the sensors, the services. I think we can dive right into the actual 3 services which you already have presented. Thank you both. Before we do that, we will just have a little poll prepared again, which should be coming up right now. Question 2, for all the participants, how often would you say satellites are involved in potential collision events? That's a certain interesting one. Let's go ahead. We have 4 options, from never, rarely, once a month to every day. Choose now, please, and remember to click submit. Okay, time is out. Let's see the results. Voila, every day. So that's a clear vote. And second best guess, so to say, is once a month. Well, I'm not going to preempt any of the statements from our experts. So I think that's it's a good start for going into the next topic. For the collision avoidance, we have 4 speakers in total. We start with the first 3. Let me introduce Cristina Perez from CDTI. She's been working in the space domain since 10 years, at the beginning in close cooperation with the Spanish Ministry of Defense, working on the programmatic and industrial aspects of the Spanish space programs Finally, she joined CDTI in 2016 as technical officer for the SST program, and she's now the head of operations and services of the Spanish Space Surveillance and Tracking Operations Center. That's impressive. Our next speaker is Florian Delmas from CNES. He works at the CNES, obviously. He's responsible for the SST operations and the services of the COO-OCC, the French SST Operations Center, which together with the Spanish Operations Center is in charge of the collisions avoidance service provision. So great that we have these two together. And the third speaker and the first part of the slot is Joao Alves, my colleague from SATSEN. He's the head of our SST unit within the Capability Development Division of SATSEN, and he was involved in several SST-related projects for several years, including the initiation of this activity, contributing to the services establishment, the evolution, and the service provision. I'll give the floor to Florian. I think Florian is the first speaker today. Just to put on the microphone, the bottom left. Yep, here we go.
Excuse me. So I will present you and my colleagues the collision avoidance service. So we'll first start with an overview of the service, followed by the key features and products, then the operation flows, the events, and to conclude the presentation on the portal, the metrics, with the users. The collision avoidance service provides a risk assessment of collision between spacecraft or between spacecraft and space debris, and the aim is to generate collision avoidance alerts. We analyze all available information, for instance, the measurements coming from sensors contributing to the EUSST, or external convention data message, for instance, provided by our American partners from the 18th STCS, in order to detect the close approach and to categorize them in different levels of risks. The service is user-tailored, and as we allow the user to configure a threshold for risk level categorization, and the advice on the collision avoidance maneuvers. So the user is able to configure the geometrical, probabilistic, and time concept. We operate the service in a quite redundancy scheme involving the French and Spanish OC, so the COO and the SST. So the two OC will provide the same service for all spacecraft. I mean they will perform the same task for all spacecraft, but only the nominal OC will contact the users and provide products on the service provision portal. The redundant OC will only take the lead if the nominal OC requests it in case of error. We define 3 levels of close approach. So the first one are the high interest events. These are the close approach with a high level of risk. They may require a collision avoidance maneuver by the user. The second one is the interest events, which are close approach, which require further analysis due to a medium level of risk. And high interest event and interest event are both always uploaded on the EUSST service provision portal. Info event are close approach with a low level of risk, and depending on the configuration, we may upload them on the portal. When a high interest event is detected, we will send a tasking request to all sensors contributing to EUSST. We will of course provide a set of products to the OO, and when needed, a direct dialogue is always available with the OC, as we are on call on a 24/7 basis. So we can help the OC to better understand the situation. We can explain him the products provided, or we can discuss within its constraints to improve our proposal for collision avoidance maneuvers. So to provide the service, we will use all available information. Firstly, we will try to refine as much as possible the hard-body radius of all objects. Sorry. Here, so we will, for instance, use the discourse database from ESA to refine this hard-body radius when possible. We can also, when the user sends us information, take into account the attitude of the spacecraft of the primary object to project the spacecraft into the conjunction plane and decrease the primary object hard-body radius. We will always perform the POC sensitivity analysis, so which leads us to the next point. One source of orbit we received are the 18th SPCS CDM. So the first point that we do is analyze this CDM and compute a scale POC on the risk level based on these refined hard-body radius. And the second point, we will receive the from the users. We first use the variance abacus, and we can also use them for calibration purposes. So we will use the OO ephemeridess to generate an improvement of the 18th SPCS CDM. We will also use a measurement received from all sensors contributing to EUSST to generate an autonomous catalog of orbit. And we will then generate autonomous products, what we call ops versus CAT products. And the last kind of products are generated using the special perturbation ephemeridess from the 18th SPCS. So we can generate those products, for instance, when risk was detected, and when the orbit determination from the secondary object changed by a lot, and when it goes out of the screening volume of the primary object. And so we do not receive the US CDM anymore. So using this ephemeris, we can confirm that the risk is that the secondary object is out of the screening volume, and that there is no risk anymore. And of course, the last point is the CAM support. We will help all the users to define the CAM, the collision avoidance maneuvers, taking into account their concerns. And so we can discuss with them to define the best scenario. And we, of course, we will screen after maneuver. We will always screen a maneuver against the rest of the catalog to ensure that no new risk is detected. And I will pass the floor. Sorry, there is one more slide. So we provide products, of course. The first products are CDM, which are standard messages that we use to exchange information on the conjunction with the users. We include the source of orbit in the reports so that the user know which products was generating using which ephemeris. The second products are collision avoidance reports, which complement the CDM. And we provide additional information such as the risk level, the scale POC, and plots such as the conjunction plane here, and the risk evolution of the risk evolution of the conjunction. Finally, we provide a monthly report to summarize all the close approach analyzed during the months. And I will let the floor to Christina, which presents you the operational flow.
Thank you very much, Florian. My name is Cristina Perez, and leading the SST OC that is providing the CA service together with the French colleagues. So I will keep on the explanation of the operational flow. It's been already explained by Marian, so I'm not going to spend a lot of time in this slide. I just want to focus on the specific of the CA service. So the regular screening are done within the national databases that take the measurement from the EUSST database, and so we ensure that we receive all the measurement from the seven countries. These measurements are processed at the operational centers, and as Florian already explained, we do some assessment of the risk with put the hypothesis radius, we compute the scale POC that we call the CA service. So we produce the CDNs and the CA reports that are delivered through the EUSST portal directly to the users. And just in case we have a high interest event, we establish a dialogue with the users in order to better assess their needs in this case of a high interest event. In this case, we send the tasking request to the National Census Operation and Control, and we receive additional method to have a more accurate orbit in our national catalog, so we can provide a better service, or at least more accurate. What we call high interest event. So this is defined in the service configuration document, that it's a very specific document where together the OCs and the user define the thresholds that are based on geometry and scale probability of collision, but it's also defined the way we communicate with the users and the constraints on the maneuver support. Because, for example, some of the users may have constraints in the delta V's, some of the users may have constraints in the time to DCA to perform a maneuver. So this kind of information is all put together in this service configuration document, so the OC knows in advance what is the best service possible, or the best service we can offer to the user. The next slide. Okay, some updates, some news from the last year webinar. We have in the left-hand side updates from our US colleagues. In the 31st of August, we released a new space track handbook for operators. We have been analyzing the impact and the consequences in our service. One of the main ones is that we receive less CDMs than before, and that's why, because mainly they have put some constraints on the release of the conjunction data message. So now they distinguish if you send them the ephemerides or not. If you send them the ephemerides, the criteria to release CDNs are more or less the same as in the previous handbook. But if you don't share the ephemerides with the spacecraft, they have put additional constraints as they don't release so many CDNs. For example, in the deep space region, they only release information if you are within a screening volume of 5 kilometers. And in the near Earth region, they have a constraint on the DCA that it's only 5 days and the probability of collision of -7. However, we are aware that some of the users are unable to share the ephemerides with a spacecraft for several different reasons, because they are not able to generate them themselves, or because they are non-maneuverable spacecraft. So the OCs perform the screening against the SP catalog in order to ensure that no additional risk is missed. Of course, we do the same with our national catalogs, but this is a part of our regular process. This is only in the case that the owner-operator of the spacecraft cannot generate by themselves and share with the spacecraft, their own ephemerides. On the right-hand side of the slide, you have news from EUSST side. We also have some improvements in the last year. You know that the detection of the high interest event and the interest event are based on geometry and scale probability of collision. The scale probability of collision is a parametric analysis of the position and uncertainties of both objects in an independent way. This parametric analysis is based on the scale factor computed in a fixed interval. It's between 0.25 to 4. However, based on the experience of the analysts over this past year, we noticed both France and Spain that in some cases this interval is too big. For a best assessment of the situation, this interval is recommended to be shrunk. What for is sometimes you see the conjunction that is very stable, or you have a really accurate secondary with very low covariance, for example, and this process is done manually. It was done manually by the analyst in the operational center based on their experience. However, in order to be prepared for the increasing number of CDNs that we expect to receive from GISPOC in the near future, with this mega constellation you were asking to Marian in the previous session of question and answer, and with the evolve of the space environment, we developed a method to automatically compute these intervals. This method was deeply explained in the collision avoidance workshop in Paris last year, and now it's operationally in place in both operational centers. And now we are getting into the real events. I know that you've been waiting for an hour hearing us speaking about general things, and now we have it. This is one geo case. This was between a geosatellite and a geo-large debris. We detect for the first time the event against the SST Catalogue 2 weeks in advance, but shortly after we detected the event autonomously. We were receiving measurements from the different telescopes in the EU SST, and we confirmed that the event was happening. Our first autonomous product was released on the Christmas day, so very nice present for the operator. Shortly after, we received the first CDN from the US colleagues, as expected. Nothing to worry about because it was info level. However, in our regular screening of the ephemerides of the owner-operator, they include an station keeping maneuver in the ephemerides, and this turned out to be an alert event. So we put in place all our procedures. We touched the sensor in the EUSST network. We start receiving data. We were in close cooperation with the owner-operator to see different possibilities. There was a big large debris, so we were able to obtain like 100 tracks from 8 different sensors within Europe and outside Europe. So it was really well tracked object. You can see here in the image that the covariance is really low. We were analyzing different possibilities with the operator. We were delivering autonomous product for 4 days until TCA, assessing the possibilities to advance the station keeping maneuver or to propose any avoidance actions different than the one the operator was thinking of. At the end, the owner-operator decided to go with the station keeping maneuver. The probability was really low. The radial distance was quite close, you can see here, but the mid distance was more than 2 kilometers. So at the end, the owner-operator is the solely responsible for this decision, and we were supporting him during the whole process. Next event is in MEO. It was an interest event. It was not high interest event at the end, but we would like to talk about this event. Mainly because there is few events to analyze in these orbital regimes, and most of them are against eccentric objects. We were able to compute the most of the event autonomously. not using the tasking request because, as I mentioned, it was never a high interest event. So we were receiving data from several telescopes within Europe and outside Europe. So we were, most of the event was monitored. At the end, we received confirmation from GSCOP that the event will decrease the risk level to info. But the specifics for this event is that 1 month later, this very same secondary was involved in a very similar conjunction with another different primary, and we were not able to see it with our autonomous measurements. We noticed this is a difficult situation that we are facing against these eccentric objects. So we decided to launch a specific observation campaign in MEO in order to better track these objects and to have a better orbit. It's not just a single shot of campaign. It will be regularly launched in order to have this in our national catalogs more accurate to provide a better service. And now I give the floor to Florian, and he will be explaining more interesting cases.
Florian, just open the mic, please. Thanks.
Sorry. So I will explain you. I will present you two LEO cases. So the first one is an high interest event with a collision avoidance maneuver. Scale POC was rather high, 2.5 to 3. The distance at decision was less than 300 meters. So the timeline was before 100 hours. There was no risk detected. The first, so the second update of the object. The scale POC was above a warning threshold, so the event was uploaded as interest event. The third update, 64 hours before TCA, the scale POC was just at the threshold 5 to the -4, and we then warned the user that the maneuver may be possible. Next update, the risk level increased again above 1 to -3. We recommended the CAM to the user, which was confirmed to this next update again 1 day before the TCA. So we helped the user to compute the CAM. We screened this maneuver against the whole catalog to ensure that no new risk was created, and the maneuver was inserted in the user FMRE. And the two last CDM, we have new updates of the secondary, and the risk, it was confirmed that the CAM allowed the risk to be avoided and was performed half an orbit before TCA. So you can see here the conjunction plane and with the various update of the secondary object, which closed up to the primary object here. And here you have the effect of the maneuver, which increased greatly the radial separation. The second plot is the probability of collision of analysis. So we apply scale factor from 0.25 to 4 on the primary axis, on the primary object or the horizontal axis, and on the secondary object on the vertical axis. So it gives us the matrix of plots, and you can see that it was mostly red, so above 1 to the -3. So the maneuver was necessary. The third plot is the abacus we use to help the user to define the collision avoidance maneuver. So here the threshold was 5 to -5. So on the purple points, So on the vertical axis, you have here the change of semi-major axis from -100 to +100, and 0 here. And on the horizontal axis, you have the time of maneuver, so half an orbit before maneuver, 1 orbit on the half before, 1 orbit on the half before TCA, 1 orbit on the half, and 3 orbit on the half before TCA. So we aimed for the purple here, and the user performed a maneuver from -55 meters. And the last example of events, it was interest event, but fully autonomous, as it was a conjunction against a large object which is absent from the US public catalog. So 157 hours before TCA, the French OC detected the events and sent a tasking request to all EUSST sensors, as we knew that we won't receive any update from any information from the US. We received the sensor data, and so we saw the risk level decrease. And finally, so refining this data allow us to refine the secondary orbit, and finally the risk level decreased to info level, and so no maneuver was needed. But it shows that EUSST can track objects that are not in the US catalog, and we have such cases a few times per year against large objects in zero. And I will pass the floor to Joe, which will present you the report.
Thank you, Florian. Thank you also, Christina, Oliver for the nice introduction, and Pascal for the kind words. Pleasure to be here today. Also hope everyone is safe and healthy. As Florian mentioned, I'm going to present the service provision portal, which is under the responsibility of SATSEN in this cooperation with member states, where we do as well other activities such the user interaction ones, as mentioned by Marianne before, which are the ones responsible, for example, for the organization of this event. Thanks to the team we have. Going directly to the portal, as you may know, especially for users, the service provision portal, in particular for CA, is the interface where you can have access to the CA products, to download them either through the API or through the web interface. It's also the interface where operators upload their ephemerides and maneuver information, again, either through the API or the web interface. The portal also allows to see how conjunctions are evolving in terms of certain parameters, common ones, probability of collision and miss distances. Certain documentation, for example, the service configuration document is also available there for the operators to download it. It's also possible to customize, to configure the emails notification. And last, it's also possible to access the service monthly statistic reports in the portal. As I mentioned before, it's possible to see the evolution of certain parameters. This is just a slide exemplifying that, both for the missed distances and the two POCs, the normal one and the scale POC. I take the opportunity of this event to announce to users that we are developing the new service provision portal that we expect to be available early next year, where we are redesigning the user interface with modern technology. We are also doing many back-end improvements, so the user experience will be much much better. In a certain way, we are also integrating the services products in the portal. So you've seen before that, for example, we have CA reports, PDF reports. We intend and we hope to be able to integrate the information that is available in these reports in the portal. We will as well improve the email notifications in terms of content, also filtering that can be done. And we'll have as well feedback mechanisms for users to provide their feedback and their needs. More specifically for CA, we will have a new event page with a timeline, somehow similar to what you've seen before in the events shown by Christina and Florian, where the users will be able to see the different products uploaded and how the event has evolved in terms of severity. The ephemeris upload will also be improved. We will process somehow the information to identify it per spacecraft and to be able to display it in this timeline. The user thresholds, what is documented in the service configuration document, and at the end what makes HIE or an interest event or an event will also be available to users. And the last point is that the operators will also be able to manage their fleets, constellations, access among their flight dynamics teams. On my next slides, this was somehow already presented by Marianne regarding our users community, but it's focused on collision avoidance, where we have more than 25 organizations receiving that service. You have the logos of the organizations there. 50% of those are from governmental institutional organizations. Being more specific, we have here again the number of satellites, almost 150 satellites registered for the collision avoidance service, and the separation per orbit regime, where we can see 46 in LEO, 13 in MEO, and 71 in GEO. In LEO, we have Earth observation satellites, also some CubeSats. In MEO, we have, of course, Galileo and some satellites from O3b. And in GEO, we have many telecommunication satellites and also the meteorological ones, the METEOSAT 8, 9, and 10, and 11. You can see also below an image showing the longitude distribution of those satellites, which is also aligned with the sensors network and with the capability to provide the services to those users and satellites. Now my next slide focuses on metrics, on high-level metrics regarding the service. So this is somehow related with the question you had before the beginning of this slot. Here we have the number of events, the number of conjunction events. We had this here. Maybe it's not very visible in the slide, but the vertical axis is in a logarithmic scale. We can see that on average we have per month around 2,000 conjunction events. They are color codes according to the severity levels, as explained by Florian at the beginning. We have the high interest events, which are the most critical ones. We have as well interest events and information events. Focusing on the high interest events, we can see that we have roughly 30 per month, which on average makes that we have one high interest event every day. This is of course on average and may vary according to the orbit regimes, either if it's on LEO, MEO, or GEO. On the right part of the slide, we also complement this information with the number of autonomous products that have been generated for these events, with more than 60,000 products generated and provided to the users based on EUSST contributing sensors. My last slide, and I'll be quite quick, is again aligned with the responsibilities of SATSEN in EUSST. We are going to launch in the next weeks the third user feedback campaign in order to receive feedback needs from users and to be able to align our developments. I've mentioned the portal. Of course, the portal will not be only developed till early next year. It's a continuous development as well. The improvements we've seen in the services, this is a mean that users have to provide us feedback, and of course it's very important to have it for us to be able to provide the best services possible. And this is it on my side. Thank you for your attention. Back to you, Oliver.
Thanks a lot, Joao. Thanks also to Florian and Christina. I think that was a very nice way of introducing the first of our three services. So that's really great. And now we stay in the same slot, but we hand over actually to we changed the perspective. We go into the user perspective, and I'm very happy to introduce Pierluigi Righetti from EUMETSAT. He works there since 2004, and for the last 7 years, he's actually the Flight Dynamics and Mission Analysis Manager following the collision avoidance method since 2009, with many interactions with different service providers, NASA, CNES, ESOC, and the EU SST. I think it's really good now to change into this new perspective, and I'm very happy to give the floor to Pierluigi.
Good afternoon, everybody. I hope you can hear me well.
Yes.
Perfect. So I will start. Okay, right. Wrong direction. Okay, now it's good. So I will present you a bit what we are doing in EUMETSAT in terms of CA. First of all, I have a brief history of how our system evolved, and then how we have been integrating it with the new EUSST. And then there are a few interesting cases I want to show you to highlight, which is the added value provided by EUSST, and which are the various cases we are sometimes faced with. And then we will speak a bit about the future, new constellations being launched by EUMETSAT, and also not only by us, and changes into the system that are ongoing. So EUMETSAT is the European Organization for the Exploitation of the Meteorological Satellites, and it's an intergovernmental organization, and there are 30 member states that you can see here. So these are our member states, and what we're doing, we're just supplying satellite data for weather and climate activities to the National Meteorological Services, and that is done in near real time, 24 hours per day, every day in the year. And to collect this data, we are operating a fleet of geostationary satellites, the 4 MSG, Meteosat second generation, and low Earth orbiting satellite, the 3 METOP satellite, and 2 Sentinel-3 satellites. And we are in full power to develop the new generation of satellites. So MTG and APS-G will be launched in a few years, and Sentinel-6, which will be launched in, this Saturday, actually, so in very few days. I'm going into the wrong direction again. But okay, so how is EUSST integrated with EUMETSAT? So that is a little picture that depicts the interaction in terms of data flow between EUMETSAT and EUSST in the case of METOP. For METOP, we have 2 other actors which are present. One is the 18 Space Control Squadron, which is in charge of operating the US radars. And being METOP a satellite in the frame of cooperation with NOAA, we have got also the support of NASA CARA, who actually is the one who is feeding CDM to our space track website based on observation data provided by the 18th Space Squadron. NASA is also interfacing with our SPACON, providing summary reports for triggering the alert. But on the other side, EUSST has got full visibility of everything that has been posted by NASA on our website, so they can as well perform collision avoidance activities and keep us in the loop either through the portal that has been presented by Joao, or directly through a face-to-face coordination through email and telephone call. And EUSST is also helping us in completing the integration with NASA. So we are providing them with our orbit, and they are forwarding it in the format, in the correct format to NASA, as they have got more interfaces with them. So that is the way we are organized. For MSG, situation is very similar. Okay, we don't have NASA anymore in the picture, so data are directly posted by the 18 Space Control Squadron in the web. And we have two partners in this case. One is EUSST, who is doing for us exactly the same thing on the GEO and on the LEO satellites. Well, what I was forgetting to mention that EUSST provide access to European, to EUSST asset, radar and telescope, but that has been already mentioned by a few other presenters. On another support we get in the GEO world is through SDA, Space Data Association. They are mainly in charge of performing analysis of operator versus operator orbits, as they've got visibility of nearly all the operated GEO satellites which are in our neighborhood. So, how our system evolved? Well, I missed a slide. Ah, yes, I missed the slide, the second slide. So how our system evolved. So the first emergency conjunction message that we received from JSPOC was, you can see, in Christmas, a very nice Christmas present. And we received this alert with only radial covariance information, and we had to compute the POC manually. Then we started working with NOAA, and we developed our first CA prototype using the data provided by NOAA. Eventually, we managed to get the support from JSPOC, who provided us with CSM. Our first CAM was in 2011, and up to today, we have been performing around 16 CAM on all our fleet. And we integrated then the support of JSPOC with the support from SDA and CARA. I've been already presenting it before. And eventually, we started also cooperating with CESAR in 2014 through a trial, and 2015 through a proper service. We integrated SOJAC in our system we've been developing previously. And in September 2016, we started integrating the EUSST services. At the beginning with CESAR for METOP and Talk for MSG, and then in 2018, EUSST took over the full prime services with CESAR as a backup. So this one we have already seen. Here, a little plot of our operational flow. So normally what we do, we receive the data, we analyze them, and we decide whether the conditions are such that we need to prefer a maneuver. In this case, we call for an escalation meeting, where we decide when to perform the maneuver based on operational constraints and also potential benefits in anticipating a maneuver. That is done more or less 24 hours before. We decide when the maneuver is to be performed, and so when is the last point in time when we need to confirm the maneuver. In this period of time, we hope we receive more data. If we receive more data, so we request more tracking as much as possible. And when we get to the go-no-go point, we decide whether the maneuver has to be uploaded. Normally, we need to have a certain lead time before the execution of the maneuver to load the maneuver on board and prepare the satellite for it. In case of urgent need, we can, however, compress all this operation, and we are able in only 6 hours to go through the full loop of activity. We are trying to squeeze even further this time. So what are the benefits of EUSST? Well, I think we have already been presenting them. So they are very good in providing us alert in case there is an high risk event. They can provide us risk estimation using the standard POC, and not only the standard POC, which is in many cases very useful for a double assessment of the risk. They can support us in consolidating the risk mitigation strategy, and they can trigger, European tracking asset in case of need. They can analyze the post-CAM status versus the existing CDM, and also through their independent mean, they can support us in geo conjunction and GS ground segment calibration activities. And thanks to the access to the special perturbation catalog, they can also provide valuable support in special operations. So now a few operational cases. The first one is quite fresh, is of this summer. As you can see, we were receiving from ST Talk a very nice red diagram which showed that we were in a very high case of risk, even considering the normal risk, but also considering a change of potential risk in the future. In this case, the maneuver, the risk was materializing on a Sunday, but being the situation so clear and being the stability of the risk very consistent, we decided to anticipate our maneuver to perform it before the weekend, and also to initiate a control cycle for our satellite. We did therefore a maneuver which was a bit bigger than the one we would have liked to perform. We were targeting 5 millimeters per second, but unfortunately was not possible because of another conjunction being present. And we did well to do the maneuver because the final POC we computed assuming no mitigation was extremely high. Another case I want to show now is for GEO. That is a bit older, but in GEO the situation is much quieter, so there are not so many cases. So we were receiving a quite interesting case with a POC of 1 out of 3,000, so we deserved certain attention. Why I'm presenting this case? Because in this case, we knew that we had to do something, so we asked both CNES and CTOC to perform independent tracking on both the object and our asset. And somehow they managed to confirm that what we were receiving from JSPOC was consistent, and therefore that the risk was a real risk. And that's why we decided to perform a CAM anticipating routine maneuver in order to avoid the materialization of the risk. But we had several other cases during the last years. I'm just presenting very fast a few of them just to see also other things that deserve to be taken into account. So earlier last year, we had a case where, according to our standard criteria of POC, we shouldn't have performed a maneuver. But nonetheless, the information coming from EUSST on the scale POC was quite worrying. Therefore, we decided to have a further look at the probability of evolution of the risk in area risk, and we decided to perform an anticipated maneuver. So that is a case where we can see that the scale POC is very useful in observe an anticipated risk with respect to the POC. We had another case where, unfortunately, the scale POC was giving us a signal, but not strong enough for us to consider performing a maneuver. But then we discovered that we should have, on truth, performed the maneuver, because a few hours before the event, the risk went high during the night. So now that opened a lot of discussion on whether it could have been possible to better handle the risk a priori, whether there are margin to improve the prediction capability. But above all, on our side, what we took is an action to whether it is possible to even further reduce the reaction time by pre-preparing a maneuver, so that we don't need to discuss on what to do. If we know that the risk can materialize, we are already ready to send a maneuver on board in case the alert is received during the night. And the last case is a case where we had not negligible risk, but during nearly 5 days, we remained with no further information from our US colleague. So that showed that there is margin for increasing from a European side the support through independent tracking capabilities. So 2 words on future evolution. As I've said, in a few days we will launch JSON CS, and this one, so Sentinel-6, this one will be supported by EU SST. So during the last weeks, we went through the full integration of the system and the validation of the various data flow. And so we are ready for launch. We have been going through the needed interface testing. So looking forward, the launch, the support provided will be very similar to the one of METOP because JSON CS will be also supported by Cara, being also another satellite. And after Sentinel-3, we will start working on Sentinel-3. Currently, Sentinel-3 is supported by EUSST through ESOC SDO, but ESOC SDO will hand over fully the service to us, or the CA responsibility to us, so we will integrate fully EUSST into our working infrastructure. A few words on what is coming in the future. In the future is coming a new space fence. So that will bring better observability on objects that are currently cataloged, so that may permit easier identification of risk and an easier decision process. Nonetheless, now we are hitting a new limit, a new technological limit, which is the capability to predict in the future conjunction because of the limitation in the solar activity prediction, which I think is the next thing that needs to be worked on. A second point is that in the near future we will see much more objects appearing because smaller objects will be tracked. So we need to think how we want to handle that. That will pose a series of problems in defining a CAM, because whenever you do a CAM, you risk to find another object. And also in handling multiple conjunction cases. We may be in a situation that we have so many conjunctions that we need to develop strategy for global minimization of the risk. And we may even be in condition that we may need to accept some risk for objects because we cannot mitigate all the risk we have got in front of us. So we need to find a way to qualify the risk, not only in terms of probability, but also in terms of impact on our mission. Then in terms of EUSST, I am expecting that the EUSST network will improve in the future, so we will have better access to independent European data that we have already been seeing are very useful in GEO, and we hope that will become more and more useful in LEO, because even if our US colleagues are providing an excellent support, we have seen that there is still margin for having added value from EUSST. Also taking into account the evolving scenario in terms of debris and super constellation. So I think that is my last slide. Yes. So if you have any question.
Perfect. Thank you so much, Pierluigi. I think it was really interesting to switch from the introduction to the collision avoidance services now to the user perspective. And you raised a few issues on future developments and requirements for future services. Maybe just a quick question back to Christina, if that is something you feel you would like to give a short comment on. Otherwise, we can also go straight to the Q&A, which we will keep very short.
Yeah, I will be very short, but I would like to thank you, Gigi and EUMETSAT team.
Welcome.
It's really great to work with you. You provide always really good feedback, not always positive, but always really good. So that's why we can move forward. We take note of all your suggestions. We hopefully in the future enlarge our sensor network and will be providing you with more autonomous products, of course. And now we have this close cooperation, and will be there are several studies ongoing for analyzing the impact that you already mentioned on the space fence and our US colleagues, but we also are eager to collaborate with you to have a more operational response that fits your needs. And that's it. I hope I've been very, very brief because we are short of time, but thank you, Gigi.
You're welcome. Yeah, I think we have to thank you for the excellent support. And we will need you more and more in the future, the more we are increasing our fleet.
We are on the same ship.
Perfect. Thank you so much, both. That's really excellent. I see some quite good working relationships here. That's how it's supposed to work. Let's then do one or two quick questions, and yeah, maybe you can focus on a short answer. I'll ask one to Florian. What's the criterion for declaring a close approach, whatever risk level is associated with it? And then straight afterwards, one to Christina. Have you noticed any impact due to the new space fence radar from the US? Maybe Florian can start, and then without any break, hand over directly to Christina for a short answer both, and then we'll take a short break.
Okay, so close approach, we will screen the ephemeris of the primary into in the screening volume. So we will use the screening volume. So for instance, in LEO, we will typically use a volume of 2 kilometers in radial and of 44 on long track and 51 on cross track, and will detect any object within crossing the ephemeris within this volume. So it's LEO 1 or 2 screening volume of the US 18 SPCS. And then when we detect the close approach, we will compute the geometry. We'll compute the scale POC and both the scale POC and the geometry will then give the risk level according to the CD, to the specification document. So, for instance, in most LEO, for CNES LEO, the interest event is at 5 to -4, and the interest event is 1 to -4 without any screening volume, without any geometrical distance. I mean. Okay.
Thank you, Florian. I think it's my turn. That if we have noticed any impact due to the new space fence radar from the US, the short answer is yes. We have noticed something, but no new objects. We have not seen any objects starting from 8. But we have seen some of the CDNs that increases suddenly the alert level, and the next day is just info level. So we maybe be because of the space fence tracking, but maybe not. We keep on monitoring the situation, and we are having more and more eyes on it in order to anticipate to these new fence releases.
Perfect. Thank you all speakers. I think that's excellent. That wraps up our first big slot. I would say, given that we're doing fairly okay with the time, but just like a 15-minute overrun, I would say we kind of shorten the break just a little bit. So just to get up, stretch the legs, grab a cup of water, whatever you want to have. If everybody agrees, my time is now 15:47, nearly 48. I would say let's meet again at 53. So just have a 5 minutes break, and then we will start with the second part of the webinar today. Okay, see you in a minute. All right. Welcome back, everyone. It's a pity I can't see you to see if you're really ready, but I'm assuming you are. So before introducing our next slot and our experts on fragmentation and re-entry, we would again like to ask you a few quick questions. Here we go. Question number 3. How often would you say a fragmentation event in space occurs? Again, 4 answers: once every 5 years, once a year, every 2 months, or once a month. You can click on now and remember to press submit at the end. Voila, time is over. Let's see the result. Here we go. So most people think once every 2 months. Second biggest majority group is once a month. I guess we'll hear something from the expert in a minute. However, we have another question prepared for you. Question 4, how many large objects have re-entered the Earth this year? This year meaning from January to November. Now is mid-November. Now you have more options. You can say anything from none to more than 50 in the whole year, starting January 1st, 2020, the beginning of a very special, unique, and sometimes confusing year. Anyway, time is running. Click on the result, 3 seconds, and submit. Okay, time is over. Let's see the result. Here we go. It's a bit more distributed. So we have quite a distribution between 5 and more or less 50. That's, I would say that's the 80% group we have. Well, thank you very much. That gives our next speakers, I think, a broad idea of where we stand in terms of our audience and how many future experts we have in the field of SST, fragmentation, and re-entry. The next slot is with the title EU SST Operational Fragmentation and Re-entry Analysis Services. I'm very happy to introduce as our first speaker here, Lieutenant Moreno Peroni from the Italian MOD. Mr. Peroni joined the Italian Air Force in 2009. In 2014, he was selected for the Aerospace System Engineering Group of the Flight Test Wing, where he has been involved in the development and management of the Italian SST Operations Center. So we have quite a few Operations Center here represented, with a particular focus on re-entry and fragmentation services. So that's really perfect. That's exactly the topic we're having here. And as the second speaker, we will have again my colleague Joao Alves from the SATSEN, whom I introduced already in the last slot. Therefore, I give the floor now to Moreno.
Thank you, Oliver. Thanks to all. Good afternoon. Okay, that's the outline of my presentation. After an overview, I will show you some key features and products for the fragmentation service. Then we will be on the operational flow very quickly, and then some nice events that we managed during the last months. Then the floor is again to Joao for the portal. Well, we just heard about the CA service, but a fragmentation actually can come from a CA event. So it's something that we don't like, actually, but it's one of the consequences of the of a CA event. We can also have a fragmentation after a main satellite failure, as well as after an explosion of let's say, an abandoned rocket body. So we try to analyze those events when they happen and try to retrieve as much information as possible in order to provide you with good reports and good analysis. Well, what are the key features of the service? The fragmentation can give you 3 products. The first one is the short-term notification, just right after the fragmentation confirmation. Then, within 3 weeks, we can provide you with 1 or more medium-term reports. And then, in 3 months, we can provide you with a long-term report. As for CA service, we always try to involve all the sensors in the network, in the EU SST network, in order to gather as much information as possible, measurements, because we need measurements to produce fragments orbits. And sometimes for particular important events, like it was done for the ASAT Microsat R in 2018, we can also give you a dedicated page on the portal with much more information about the event itself. Well, the products. Let's start with the short term. The short term is a very fast information that we try to do and send to you. It just contains the type of fragmentation, the objects involved, the orbital regime, as well as the number of detected fragments. Sometimes we can take some time to provide the fragmentation short term because we have to verify information when they derive from outside the consortium or outside our partners. The medium term. For the medium term, we actually propagate the fragments cloud for a time span of several weeks in order to put in the report the evolution of the fragmentation. It's something that the user wants. We put in the report the distribution of the fragments with the well-known Gabbard diagram. We put in the reports 3D pictures of the evolution, both of the parent objects and of the evolution and of the fragments. We also include in the report the dispersion of the orbital fragments parameters. So the report is growing over time, as you can see from the portal. The long-term period is mainly on simulation. So we use real-world information to set the conditions of the simulation. And with our models, we can reproduce the event and assess several useful outputs. For instance, we apply a breakup and collision model, and we can retrieve from the simulation the area over mass distribution of the fragments, the delta velocity distribution, the spatial density evolution over time, and a nice thing is the number of fragments expected greater than, let's say, 10 centimeters, for instance. This is important because always we can just track a part of the fragments involved in an event. So the simulation can give you an outlook of the enormous number of fragments that usually you can have from an event like a fragmentation. Okay, and sometimes we can also apply our simulation to potential fragmentation. We have done it a few weeks before for a potential collision between the Cosmos 2004 and an old rocket body, a Chinese CZ-4C rocket body. So we can also apply our tools in order to assess the risk derived from a potential collision. Okay, the operational flow is very similar to the CA1. Here the important things are that we have a link with our partner in the US, so we can exploit information from SpaceTrack. But the very important thing is that we always involve our network of sensors, as I said before, and then we use the information in the database to compose our analysis and our reports for you. Well, now some nice events. This was an event involving a Japanese fairing section of the H-2A rocket. The orbital regime was very dangerous because it was in LEO, so very populated area, as you know. We got 53 fragments. And if you see at the event timeline, after the detection, we we provided the short-term report, and we issue a tasking request to all our partners in the consortium. Actually, we were able to issue a couple of reports using information from our sensors. And this is an extract from that report showing both 3D pictures of the event and some graph with the well-known Gabbard diagram on the right side. Sometimes we also put in our reports some outcomes from our sensors. In this case, the report included a contribution from a survey radar, and you see the calculated trajectory and the actual trajectory of some fragments. So it's something that we put in the report to show you the capability of our sensors or of our network for fragmentation, for the fragmentation service. And another event was about the Fragdeb. It was a tank actually fragmented in 2015, and now producing 65 fragments at least. Again, it was an elliptical orbit in LEO, so was crossing several altitudes in LEO. Again, a potential hazard for other satellites in LEO at several altitudes actually. We provide the report and the Gabbard diagram also that time with information from our sensors, and we put also in the report a contribution from a B-state radar on left side. So the radar was able to detect fragments in the cloud, as well as a telescope, more than one telescope was able to detect the fragments of that event. And this is again something that we want to show you in order to assess the capability of the network. Okay, and now the floor is for Joao for the portal part.
Thank you, Moreno. So hello again. It will be a similar presentation than the one before for collision avoidance. SATSAN is responsible for the service provision portal, in particular for fragmentation, is the interface for users to download the fragmentation products, either through the API or through the web interface. Again, it's also where users can find technical notes, as Moreno mentioned before, dedicated technical notes for certain events. It's also the interface that alerts or warn users through email when new events happen, and it also allows the users to download monthly statistics on fragmentation events. As for CA, we are developing a new portal, hopefully to be available early next year, where once again we are going to further integrate the products in the portal. We'll have new plots, again the timeline concept to see when an event has happened and when we have been able to update information on this event. Also be able to see how the cloud, how the fragments cloud has evolved and so forth. And in terms of users, very similar to the slide presentation presented by Marianne at the beginning of the webinar. For fragmentation, we have more than 70 organizations registered and receiving the service. It's a more diversified user community than for CA, where for CA we have mainly spacecraft owners or operators. Those also receive the fragmentation service, as it can be, of course, useful for them. And we have as well some users related with industry and academy interested in the service. In terms of metrics, and also related to the question that you had to answer before the beginning of this slot. These are the events we reported this year. On the left side, on the left axis, you have the orbit regime. So most of the events have happened in low Earth orbit. Within each of those bars, you have the number of fragments associated to each of those events. And we can see that on average, we have an event every 1-2 months happening, one fragmentation event happening. And once again, to complement this information, for those events, we've provided 8 autonomous reports, products based on EU SST sensors data. And this is it on my side. Back to you, Moreno, for the reentry service.
Thank you, Joao. Okay, the outline is very similar to the others. An overview, some key features and products for reentry, the operational flow, and then some nice events before to leave the floor again to Joao for the port and the metrics. The aim of the reentry service is to analyze the last part of the life of man-made space objects and debris when they go down in the atmosphere in an uncontrolled way. We just take care of the uncontrolled reentry. Our analysis always cover a period of 30 days, starting from today, every day. So we watch in the future for 30 days. And so the service has some key features. We apply some filter on the objects that are going to re-enter in the next days, in the next weeks. We analyze, as I said before, we take care of objects with a mass greater than 2,000 kilos, if it's known. When the mass is known, we try to use the RCS, if available, and we only analyze objects with an RCS larger than 1 square meter, and we always analyze all the rocket bodies. Another important point is that we try to involve every time, for every sensor, for every event, all the sensors of the network, because it's very important to have autonomous measurements in order to provide autonomous reports and good predictions. Another nice thing is that the final user can customize the notification. So you can just receive a notification only when the re-entry will pass over your country, if you want. So you can select as many countries as you want. The operational flow, for the operational flow, I just want to highlight the exploitation of external data, again from our main partner, the Space Control Squadron, but I have to highlight as well the role of our network, because to produce good products, we need measurements. So we try always to retrieve measurements from our sensors and from the catalog where we can find measurements in order to provide better outputs. Well, the reentry service works on 2 ways. On one end, you have the reentry, the 30 days reentry list. So we watch 30 days in the future, and we try to assess the objects that are going to reenter in that time span. On the other end, you have the reports. So a few days before the reentry epoch, we start to release reports on the portal with our predictions, with the characterization of the event, and other orbital information. Also for re-entry, for particular events, we can provide dedicated pages in order to show you more information. Okay, some nice event. This was about the Long March 5 CZ 5B. It's very popular re-entry during 2020 because it was actually a variant of a Long March 5. This time we just have the core stage, 30 meters long, 5 meters wide, something like 20 tons, so one of the most massive objects re-entering the Earth during the last years. And the nice thing is that after the re-entry epoch and actually near the calculated re-entry point, there were some findings on the web from Ivory Coast that was one of the last country overflowed by the objects. So how we managed the event, that's the timeline. It was a very fast event, just something like 6 days from the launch to the re-entry. We started with the sensor tasking, and then at the very beginning our predictions were not so good, but over time, receiving more measurements from our network, we were able to provide several reports, and the final one contained actually a re-entry point that was very, very near the Ivory Coast, where some pictures were shot. And if you look at the number of reports, we issued 10 reports, and 5 of them, like also the last one, 5 of them were autonomous, based on information from 4 EU SST sensors. For this event, I also put in the presentation a video showing the trajectory, so you can see the object approaching the west coast of Africa, and then going to overfly over the Ivory Coast. The trajectory actually stops at 80 kilometers of altitude, where usually we consider the re-entry point. So it was a very, very nice simulation for a re-entry point that was actually really near some findings. Another in this slide, I want to show you a video from a Doppler radar that was following a Falcon 9 rocket body a few weeks ago in October, and I want to highlight the capability of some of our sensors to both work in search and tracking mode. Because the orbital information that you have for re-entry can really degrade over time, and so if you want to track a re-entry object, you need sensors sometimes that can use the searching mode and then the tracking mode, or you can if you have a survey sensor, that would be the best, but also sensors with searching and tracking capability can work really, really good for re-entry. And after this video, the floor is again for Joao.
Thank you, Moreno. On my side, the presentation will be again quite similar to the ones given before regarding the portal. Again, it's the interface for users to download the service products for the 30 days re-entry list, and the user can also see how the re-entry window evolves. It's also possible in the portal to download those technical notes produced for particular events. As Moreno shown, the user can also customize where he wants to receive alerts. If he wants to select a particular EU country, he can do that in the service provision portal. The 30 days re-entry list, the notifications can also be configured there, and once again, the monthly statistic report is also available in the service provision portal. Once again, we are developing a new portal, integrating the information that you've seen before, that Moreno mentioned regarding the different products for re-entry in the portal as well, with all the developments in terms of the user interface and as well the new event page, where we will, for instance, include the ground track of the re-entry object over a map. In terms of users, again, a diversified user community. More than 80 organizations are registered to receive the service. Comparing with fragmentation, here the community of users that we have, that is a quite particular one, and you'll see that in the following presentation, is that we have as well civil protection entities concerned with these events and as well receiving the re-entry service. In terms of metrics, also this year we have had on average 4 or 5 events, re-entry events per month. These are according to the criteria that Moreno explained at the beginning of his presentation on the re-entry service. And in terms of products, we've provided 22 autonomous products based on information coming from EU SST contributing sensors. My last slide, again, the user feedback campaign, the opportunity for the users that are listening to provide their feedback for the further developments that we are doing, both in the portal and both on the services side. And this is it on my side. Thank you. Thank you, everyone, for listening. Back to you, Oliver.
Thanks, Joao, and thanks, Moreno. I think it was really a nice wrap-up of the 2 services, and in a very nice ping-pong game, you presented us the different features and the service as it is developed and also as it is presented to the front desk to the users. Now, again, we would like to take a little step and switch to to another perspective. We will have Mr. Juan Escalante from the European Commission, and Juan is actually the Copernicus EMS operational focal point at the European, and that's a very long name, Commission's Emergency Response Coordination Center, ERCC, and more known probably within the Directorate General for Civil Protection and Humanitarian Aid Operations, DG ECHO. DG ECHO, I think, really is a name that's known not just in Europe, but around the globe. And within this DG, Juan is the desk officer for the European Civil Protection Certification Process and project officer on innovative disaster prevention and preparedness projects inside and outside the EU. The issue is, again, that DG ECHO really is a central hub, and I'm sure that Juan will present this a little bit in detail. So very happy to have his perspective and how they interact with our different providers and the different services presented here. Juan, the floor is yours.
Hello, Oliver, and thank you very much. Thank you very much for your presentation, and thank you, Joao and Lieutenant Peroni, for your words. Well, exactly, we are going to show a little bit the perspective of a re-entry user. We are DG ECHO, we are the Emergency Response Coordination Center. I hope now the presentation, okay, perfect. So I don't have an outline, but we are going to basically talk about who are we, what are we doing, and why EUSST is very important for us as well. So you can see there is a picture of the ERCC with people already working there. So as many DGs in the Commission, we have a big structure. We have 5 directorates and we have 20 units. I'm coming from Directorate A, which is the one having the Emergency Response Coordination Center within it. And we have our commissioner, who is Janez Lernacic, which is the Commissioner for Crisis Management, and it was nominated by Mrs. von der Leyen as European Emergency Response Coordinator. How we delivered, I mean, DG ECHO, as Oliver mentioned, is humanitarian aid and civil protection. Humanitarian aid, we deliver it thanks to our strong presence in the field, thanks to the 7 regional offices, several people deployed on the field, and we somehow provide humanitarian aid through our partners. We have more than 200 humanitarian partners, ranging from large UN agencies to small NGOs. And as I mentioned at the beginning, we are, somehow coordinating this from Brussels from the EUSST. This is the acronym. We are monitoring different types of disasters around the globe. We are mapping disaster risks. We are the focal point for the Copernicus Emergency Mapping Service. We provide real-time information, and that's why EUSST is crucial for us in terms of a re-entry event. And we coordinate whatever, it is related with the response operation at European level through Brussels. So we are composed by 24 duty officers. We have 3 EUSST coordinators, extra staff, 10 communication officers, and 16 management on duty. To give you an idea of the staff behind the EUSST, and we are somehow the core of the European Civil Protection Mechanism that enables a good and coordinated assistance from the member states to all over the world. So as is all EU member states plus 6 participating states, which is our Norway, Iceland, Serbia, Turkey, Montenegro, and the North Republic of Macedonia. How the mechanism works? Well, it's a long workflow, but to make it, easy for you, is there's a request for assistance, reach the SST, the SST, distribute the request through member states, and then there is a delivery of assistance and the transport co-financing ongoing. We have, been activated 20 times in last year. We provided emergency in different types. And you can see from 2013, the geographical spectrum of our response. Here you can see the activations from 2007 to 2020 and the big jump due to COVID in 2020. Okay, how we build our situation awareness, where we have different sources. The most important one, I would say, is our early warning systems. So we have GDAX for earthquakes and tropical cyclones, the European Forest Fire System for forest fires, the Drought Observatory, floods for EFAS, and Meteor Alarm for the weather, and of course EUSST. And that's why we are here and how we are using EUSST. We are a re-entry user. We had a very important case in 2018, which was the Chinese satellite Tiangong-1 that we were following from the 27th of March until the 3rd of April, together with EUSST. And at that time was very important to receive information, real-time information and reports from European experts to provide and to feed the civil protection community in Europe. And it's something that, this is what I would call autonomy. And I would say, operational autonomy. And at the same time, to this year, we received many events reported in terms of re-entry that we were somehow following. From our perspective, we would like to say that we consider very value service for us, but at the same time, we would like to have something similar to the collision avoidance in terms of this color code. Info event green, interest event orange, or the high interest event red. If we have that I know that for a re-entry might be more difficult to have, but it would represent a challenge for you. But I think if we can have that color code, it would be very good for our civil protection community. That is the message we would like to pass as a re-entry user, and thank you very much for inviting us to participate. The floor is yours, Oliver.
Thank you so much, Juan. Always a pleasure to have somebody from your DG speak, and it's really such an important service which you provide. And interesting that despite that you have such a wide spectrum of activities, that you also relate to such a very specific, mostly considered technical service like SST. So that's really great. Maybe just a quick question back to the EU SST team, if they want to provide a short comment on any of the issues raised by the Commission. Joao or somebody. If not, then that's fine. Then we will go straight to the Q&A session.
I can provide some quick feedback, assuring Juan that we'll take this point into consideration. I believe in the evolution of the service, there are already some discussion on this sense on how to categorize the different events. It's true that for the other service, the collision avoidance service, this was also something done within the evolution of the service, and I think this will be as well addressed for the reentry service, because as we've seen, we have many events happening, and I think it's important for operational purpose to be as well able to do this separation. I don't know, Moreno, if you want to complement somehow on this point, but I know that this will be tackled in the evolution of the service.
Right. You're right, Joao, and we are actually working on it. We know that there are many events during the years. This year, if I remember well, they are something like 50, and probably they are increasing over time. Sometimes the European area is not involved actually in for a particular re-entry, so it's important probably to catch your opinion and try to translate it. And actually, we are working on a risk index, like a color code for the final user to assess how much the re-entry is dangerous, considering several parameters. So it's something ongoing, and we hope that in a few months we can give you this kind of information actually.
Great, thank you so much. I think we jump straight into the Q&A, maybe again with fairly short answers. At the moment, I have two for Moreno and one for Joao. Maybe Moreno, I'll address. I'll read all three so that you can prepare and then just go ahead one after the other. Moreno, re-entry reports show the estimated re-entry point, but is EU SST planning to provide some kind of ground impact risk classification? I guess that's a question that could have been asked by DG ECHO also. And the second question to you is, if there is fragmentation, how do you coordinate with the other services, i.e. for collision alerts? And then straight after, once you're done, to Joao, do you provide any kind of training? But first to Moreno for these two questions.
Okay, probably I answered before to the first one, saying that we are working on a risk index, some code, color code for the re-entry, and this could be something that can answer the question in order to give a risk classification. For a fragmentation, actually we are working on a risk analysis for the orbital region involved for a fragmentation event. It's something that shall be released in the next revision of the service portfolio. So this feature also can be ingested and processed by the CA service in order to make more analysis. So we are trying to assess right after the event where is going to go the cloud of fragments, and if the cloud is going to incur in other collisions with other satellites in the near future. So I hope that answered the question.
Okay, I will take the floor then for my question. At this moment, we don't provide any training on re-entry. I assume the question was directed to re-entry. We do not provide any training either for re-entry or for the other services. I think it's a point that we can take on board to see how we can maybe evolve on this. Saturn has experience on this. I think it could be also a good point for collaboration with member states. But no, at this moment in time, we do not provide such training to users.
Okay, good. Thanks a lot, Joao and Moreno. I think this really nicely wraps up this slot about re-entry fragmentation. And also thanks a lot to Juan, as again, adding the user perspective from the very specific requirements, the view of DG ECHO. So I think that really rounds up very nicely the presentation of the three services. Now we go one step further. We go back into the External Action Service, and I'm very happy to introduce the next topic, a diplomatic initiative of the EU in this field, titled Safety, Security and Sustainability of Outer Space, the so-called 3SOS initiative, which will be presented by Christophe Morand, who's been working with the subset for quite some years, I understand. Christophe is the deputy head of the Space Task Force in the EAS. He is the head of the GTRA duty officers, the Galileo Threat Response Architecture, at the European External Action Service in the Space Task Force. Christophe works in the EAS since 2010, in the Space Task Force before in CMPD, and originally comes from the French MOD and the Air Force. Christophe, the floor is yours. Happy to have you on board today. I hope you can hear us. Maybe to unmute the microphone if necessary.
Hi.
Here we go. Christophe, welcome.
Many thanks, Oliver, for your introduction, and good afternoon to all. First of all, thanks for inviting us to present our 3SOS initiative. First of all, apologies on behalf of Karin Claes, the Special Envoy for Space, but unfortunately she is not available this afternoon. I'm really impressed with the attendance this afternoon of this panel, and it's a pleasure for me to introduce our initiatives, 3SOS. I will go to the next slide. Yeah, it works. Most of you space experts. Then I will not explain you that many of the systems and services that are today essential for well-being and the security depends directly or indirectly on space. Space-based assets and services are essential for the functioning of modern societies, to a global economy, to international trade. And most of you are aware that it is estimated that the global economy depends for 60% on space-based tools and services. It's enormous. However, space is more and more congested. There are more than 5,000 satellites in orbit, of which less than 3,000 are fully operational. We have to take into account the risk of proliferation of space debris and the associated risk of collisions. And finally, so-called mega constellations represent a real new challenge for the future. Moreover, space is more and more contested. There is a growing risk of an expansion of conflicts into space, where it would not only impact potential parties, but the peaceful use of outer space for all users, and it is key. Finally, space is more and more competitive. Definitely, space is vital for multiple sectors, from digital economy, transport, telecommunication, banking, all those kind of domains. It is key. Therefore, multilateral approaches are needed to further develop the current normative framework in order to address new realities. The EU continuously promotes the preservation of a safe, secure, and sustainable outer space environment, and the peaceful use of outer space on an equitable and mutually acceptable basis. on our side, we consider that Outer Space Treaty, the UN Outer Space Treaty and other UN treaties are the cornerstone of international space law. Last year, UN COPROS adopted 21 guidelines for long-term sustainability of outer space activities, and it is a key contribution for a better transparency in our outer space. In the meantime, in September 2019, the EU has launched the 3SOS campaign. 3SOS stands for Safety, Security, and Sustainability of Outer Space. It is a public diplomacy campaign promoting a sustainable approach to space by avoiding collisions, reducing the creation of long-lived orbital debris, and promoting transparency and confidence-building measures in an effort to reduce the risk of misperception and mistrust in the area of space security and stability. After extensive consultation, we are of the opinion that the issue of developing pragmatic and effective voluntary norms for outer space is a real question for today. There is a need for reaction today. We need to act very swiftly. And that is the second reading of the acronym 3SOS. Those voluntary norms should be developed definitely at UN level. They should contribute to transparency and building confidence in outer space. They could establish standards of responsible behavior addressing new challenges, the so-called also mega constellation. They could establish also a notification, communication, and coordination mechanism to avoid collisions and misunderstanding. Finally, the EU remains strongly committed to the prevention of an arms race in outer space, which is essential for strengthening international security. The 3SOS public diplomacy campaign does not aim at proposing concrete measures. We have to be very clear on that. It only, the objective is just to build awareness and to create a fertile soil for concrete measures to be negotiated at global level. Definitely those measures should be defined by the relevant technical and political bodies within the UN. We are just here in a diplomatic campaign just to raise the awareness in order to allow the implementation of those future concrete measures that will be developed globally. That's it on my side, and I'm ready for your questions. Many thanks.
Perfect. Thanks, Christophe. I think that's, again, a whole new dimension or whole additional dimension from what we have been discussing so far. So it nicely rounds up the technical and procedural administrative services perspective with the diplomatic level from EU perspective. Thanks a lot. I would like to introduce a question. Here we go. Is there any link between 3SOS and the UN long-term sustainability guidelines? Exactly, that's the one. Christophe.
Yeah, many thanks. Many thanks for the question, and definitely it allows me to clarify and to stress that those two work strands are totally distinguished. At UN COPIOS, they are defining those concrete measures, technical measures. On our side, it's not at all the purpose of the 3SOS campaign. 3SOS campaign, it is a diplomatic campaign, meaning with the objective to raise the awareness and of, in fact, all the different communities, industry, think tanks, policymakers, just to raise the awareness in order in the future to implement at political level and to achieve commitments by countries to implement those concrete measures that are currently developed in UN COPROS. I hope it clarifies exactly the difference between the démarche of COPROS and the démarche of SUSOS.
Great, thank you so much. I think it's quite important to understand the different levels of initiative and how they interact on the EU level, the UN level, and obviously also the member states' various initiatives and intentions. Thank you so much. That's really excellent. Thanks to you, and we will now go to the concluding remarks by the European Commission. It's our last session. I'm very happy to introduce Rodolfo Munoz from DG DEFIS, the newly formed Directorate General. He works in the Development and Applications Unit, which is responsible for SST and future SSA components of the space program. Rodolfo has worked for various international organizations, being an expert for many EU and OECD programs. Rodolfo, the floor is yours.
Thank you very much, Oliver. And thank you very much to the SATSEN for organizing this webinar. I think it's very important because it shows what we are doing. So what I will do today is to wrap up a bit this seminar. So I will first try to show you with a sort of summary the achievement of the EU SST. It would be 1 or 2 slides, and then I will show you or introduce you with the changes which are supposed to come now with new space regulation. So as a starting point, so this is the idea, is really how we jump from SST support framework to SST component of the space regulation. Here, this is very important to understand that the EU SST has grown extremely fast. Indeed, when you look to the timeline, you see that we had in 2014 the adoption of the decision who started the process, and this has been presented by Pascal. And then we had the establishment of the governance in 2015 with the EU SST Consortium and cooperation with SATSEN. And then we started to deliver the service mid-2016, so nearly only 1.5 years after really establishing the governance of the EU SST Consortium. And we had an enlargement of the SST Consortium with a new member state joining the first member state who started the EU SST services. So you see, in a matter of 4 years, basically, we managed really to develop the system. And this system, with the main achievements, are, of course, the protection of the 2 EU flagship programs, Galileo and Copernicus, because indeed why at the beginning the EU SST was created was meant to protect the 2 EU flagship programs and, of course, the EU member state space infrastructures. Second, as an achievement, and this will be something that technical people can understand even more, is networking of 46 sensors coming from 7 different member states. This is really an achievement because it requires a lot of work, background work, and there I praise the work of the EU SST Consortium, of the TEC, which is a technical committee where you have a lot of work in order to achieve this networking of sensors. Then, of course, you have the development of a database. This is quite unique to manage at the European level to develop this database. And we have as well the future European Catalogue that we are working on it. So we don't want to stop just at the database, but we are achieving the development of a future European Catalogue as well. You have the provision of added value services, meaning that indeed we are working, of course, like Pascal said, in close cooperation with the US. We do not intend to be in competition with the US. This is not at all the idea. What we plan to do is to work together, but we have a value added thanks to our experience, thanks to our very talented people working inside our system, and as well to our 46 sensors, which you have seen are established all over the world. And as an achievement, of course, I mean, if a system doesn't work, then in the end you don't have users, or only the users which are obliged to follow the system. And you could see that there is a steady increase in the number of users, and that today for collision avoidance we are protecting 147 European satellites, meaning that we are offering CA services for these satellites. And finally, as an achievement, and this is really something important, is preparing the future with system architecture studies. This as well is done in the background of the work. What we have in mind is indeed to develop the EU SST, and therefore we have a lot of research going on. I mean, some of them have been mentioned. Regarding the consequences of the space fence or the mega constellation, but we are working as well in order to improve our architecture for the future. And the future is coming. So we had the proposal of the European Commission in June 2018, where indeed it was established that the SST will become a subcomponent of the space program. I will talk more about it. Here, I want to insist on one point. This is a proposal of the Commission and is still discussed by the Council and the European Parliament. And whatever I will present today might be changed by the Council and the Parliament. Normally, let's say that we are really approaching the final stretch, meaning that changes might happen because this is really the choices of the legislators at the EU level, meaning the Council on one side for the Member State and the European Parliament on the other side. Therefore, normally no major changes should be done, but it's up to them to decide. So I really insist that the Council and the European Parliament can still decide to make some changes, but normally the main choices have been done. Here, one of the main choice and of course on the space regulation, I will only explain the part related to SST. I will not develop the other part. But there are many other new developments. But what is very important to understand is now we have a space situational awareness component inside the space regulation. So this is really something very important to us. Why? Because it means that we are becoming a program and part of the space regulation and the space programs. You see that inside this SSA, you have the SST part, but we have as well two new aspects, the space weather and the near Earth object part. I will not develop these two. Here on the space surveillance and tracking, what we base ourselves is first on the continuity, but as well on the evolution. Here, it's very important. Why? Because as you have seen, I mean, the three main services which were established by the EU SST support framework are working very well. Therefore, we wanted to go on with these three services, the collision avoidance, the re-entry, and the fragmentation. So we will go on our work with these three main services. The governance, Pascal Fauché explained to you how the governance is working today. We will have a similar governance. The name will change. We will jump from a consortium to a partnership. We might indeed have a partnership with much more member states. This is discussed at the moment between the member states. Here, this is my my last slide, and regarding the SST new developments, I will just insist on the main one. First, it's really important, so I would like to repeat it, SSA is a component of the space regulation. So this is very important. Second, we have new services as well, which are being listed as new services for SST, EU SST. We have the space debris mitigation in order to reduce the generation of space debris, because we consider that indeed it's very good to discuss about how to avoid a collision, but it would be better to diminish the number of space debris. We will have as well a service dedicated to space debris remediation. Why? Because indeed it would be interesting for the EU to look as well how to manage the existing space debris. What is very important as well, we will have new users possible. Indeed, the possibility to have users from outside the EU should be acted when the space regulation is adopted, of course. And we have the development of expert teams, meaning that we would like to, with a new space regulation, we will have teams where experts are coming from different member states and working together in order to push for really the development of a better EU SST. So what I would like to say is, I mean, when we look backwards, we are very impressed by the work which has been made. We, as Pascal Fauché showed, we are overseeing the entire system, but this is a work which is done by the member states, and with a work involving people from the civil side, from the military side, from sensors, different member states, different locations. And up to now, we are doing quite well, and I think with the fact that we are becoming now a space component, will definitely push for more development in this field on the EU side. Thank you very much.
Perfect. Thanks a lot, Rudolf. I think that's really excellent to have your speech, your briefing at the very end, really wrapping up everything and putting into the wider political and administrative framework, seeing what we are, where we're coming from, where we are going through, and what is coming up next, including also the important roles of the different entities of the Parliament and the member states as the actual lawmakers, and not diminishing at all the Commission's role as the main proposer of these this new and possible legislation, and also the financer of this. I think we're doing well in time, so we might just have time for one question, if you allow. We have actually two. Will there be any relation between SST, NEO, and space weather? Is the first one. And another one, the latest EP Council budget iteration looks like about 28 million per year for EU SST in the 7-year MFF. What EU SST architecture improvements can be made under these constraints? If you want to answer to any of this, floor is yours again.
Okay, so regarding the first question, indeed, we will look to the potential links between SST, NEO, and space weather. I mean, the national space agencies which are involved are the same. Therefore, the SSA will be a specific committee where all these three topics will be discussed, and there are some links. Some are direct, others are indirect, and of course we will look to potential links. For example, the effect of space weather on potential calculation for SST, etc., etc. But there we will, of course, work in the same committee. Therefore, we will be able to see the potential link. Regarding the budget, there I cannot discuss this issue because it has not been decided, and this is a political decision. And you can fully understand that as long as I don't have any decision by the political bodies, I cannot discuss this topic. I'm sorry.
That's fully understandable, but we were also happy to present you this question, which came from the audience. So
of course, I fully understand the importance of the question. However, it's not in my hands, and this is really a highly political question. So I cannot.
Obviously,
yeah.
Anyone involved in the process or even looking at the process, I think, knows about it. And you made it very clear with putting the font very big in that specific slide. So thank you so much also for respecting the different roles and responsibilities. Thank you all very much. We are coming to the end, but before we close the session, there's one very important question I have to, or actually task, whatever you want to call it, to ask the audience. In fact, we are preparing a very short, quick feedback from you. It just literally takes 20 seconds. You can start right away and just put in your feedback, because it really helps us to understand what went well this time, what we can maybe do better for the next iteration of the webinar, of the SST webinar, or real live seminar. We'll see how everything evolves in the next year. In the meantime, thank you so much to all speakers, to participants, to everyone involved in this big project this afternoon, for sharing and for contributing. Big thanks also to all my colleagues around Joao and the EU SST team in the EUSST. It was such a great pleasure. I feel honored to be working with all of you. I really enjoyed this. Big number of success. We had more than 400 participants in this online seminar. So that's really something for the records. I'm very happy to be able to announce that. You will also be able to follow up. You can still send us mails with any comments or questions you have to the mail which we have indicated. You can follow us again on the Twitter, on social media, on the LinkedIn page, on the YouTube channels, and the videos will be made available in the briefings on the YouTube channel in the coming weeks. Thank you so much. All the best to you. Stay safe, and don't forget to just take a few seconds for the survey. And I'm very happy to close this webinar, the second EU SST webinar today. Thank you so much.